Around this time last year, we shifted into a neutral phase of the El Nino Southern Oscillation, or El Nino for short. There are three different phases here to this climate pattern. El Nino affects the temperatures in the eastern part of the tropical Pacific, but has worldwide impacts, and it's used as one of the indicators of hurricane activity in the Atlantic. If El Nino conditions are present, the ocean is warmer than normal off of South America's west coast, and usually that would correspond to less tropical activity in the Atlantic because there's more wind shear, whereas a La Nina is going to be the opposite, and the waters are actually a little bit cooler. But for this season, we are in a neutral phase, so we're somewhere in the middle. For the peak of hurricane season, there's more than a 50% chance that we are going to remain in neutral conditions, according to the Climate Prediction Center. However, this does not necessarily mean that we're going to see less tropical activity. It's just one of the factors that goes into accounting for forecasting for the next hurricane season. But just as we know, neutral conditions were present last season and also in the record 2020 hurricane season, both of which were well above average seasons. In a normal timeline here, we usually get about 14 named storms, 7 of which become hurricanes and 3 are major. In 2023, we had an above average amount of named storms, but we were actually very typical for hurricanes and major hurricanes. Last year, we were less active because we had fewer named storms, but we saw stronger systems. We had 11 hurricanes, which is well above average, and we had 5 major hurricanes. This year, Colorado State University is projecting 17 named storms, 9 of which will become hurricanes and 4 major. And on May 22nd, NOAA released their forecast. They do a range, but still it's anywhere from a near normal season to slightly above average, which follows Colorado State University as well. And here's a list of the 2025 names. If they do look familiar, this is the same list that is used in 2019, with the exception of Dexter, which replaced Dorian, which was retired that year. Hurricane season runs from June 1st until November 30th, and throughout hurricane season, we start with a positive trend in activity, with the most active window of time in the late summer to the early parts of the fall, and then a gradual downturn in activity through October to the end of the season. And early on, storms are typically weaker, but they form closer to the continental U.S., with named storms possible in the Gulf and up and down the eastern seaboard, where any tropical development in this area is forming off of a stalled front. In a normal season, one storm will form in the month of June. As we move into July, most of the hotspots are going to be the same as they are in June, with the addition of the eastern Caribbean in the western parts of the Atlantic, and storms that form off of fronts are a little bit more likely in July. Historically, during this month, we also get one named storm. Now, activity dramatically increases as we go into August, with the whole Atlantic basin open season for storm development. And it's at this point in the season that the main development region in the tropical Atlantic begins to warm, and therefore we see it spark to life in August. And it's also the middle of monsoon season in Africa, which is responsible for tropical waves entering the Atlantic. In the western Atlantic in the month of August is also a little bit more active. September is peak season, where tropical waves will funnel off of Africa more consistently, and some of the storms that develop travel westward, and they're usually going around the Bermuda High. That's kind of steering these storms. More than half of the season's tropical activity is expected to occur between August 1st and September 30th. Now, as we enter October, this is when we go on our negative trend a little bit, but it's typically still more active than July. The western part of the Caribbean is more likely to see named storms, and tropical waves in the main development region are a little less frequent. Activity will continue to wane in November, and the storms that develop again are a little closer to the continental U.S., are typically originating in the western Caribbean and parts of the Atlantic. Earlier in the show, we talked about formation zones and what is typical of the average hurricane season. However, in recent years, hurricane season has been off the charts, producing the most anomalous storms seen in the history of the Atlantic basin. In 2024, a tropical wave off the coast of Africa, which would usually happen in August and September, turned into Tropical Storm Beryl in the western Atlantic and would later undergo an explosive period of rapid intensification and set numerous records in the Atlantic, such as becoming the earliest Category 5 hurricane. So let's set the scene. Why was a storm as crazy strong as Beryl able to develop where it did? Well, in May 2024, the tropical Atlantic was more than 3 degrees above the May average, setting an all-time record for the month and a trend that continued into June. The ocean temperature at the time was more in line with what you would see at peak hurricane season. More than 70% of the planet is ocean, and unfortunately 90% of Earth's excess heat that we create by burning fossil fuels is absorbed by our oceans. We have an amazing tool from the Climate Prediction Center, which is known as the Climate Shift Index, which will analyze daily ocean temperatures and measures how climate change has altered the frequency of these temperatures. So, for instance, with Hurricane Beryl, when it developed into a tropical storm on June 28th, the ocean temperatures that Beryl tracked over were 90 times more likely to happen due to climate change. And the statistic is even worse when we analyze the period of rapid intensification that Beryl underwent, because at times the Caribbean was 300 times more likely to see those anomalous temperatures in comparison to a world without human-caused warming. This near-record climate-driven heat is going to act like lighter fluid, allowing the storms to blow up in intensity just like Beryl did. And the impacts of a warming climate on the 2024 season do not end there. The profound warming in the Atlantic supercharged all 11 hurricanes that we had last year, including Helene. In the Carolinas, the biggest thing with Helene was the rainfall. Researchers looked into several different tropical cyclones and found that rainfall is exacerbated due to climate change because warmer air can hold more moisture. Other huge storms that produced more rain in our warming climate include Katrina, producing 4% more rain. Harvey in 2017 was upwards of 37% wetter, along with Irma and Maria, and we even have Hurricane Florence on the list, which caused catastrophic flooding to our area and would have produced 5% less rain if greenhouse gases hadn't increased so rapidly over the last several decades. And in terms of Helene, rainfall was 10% worse. Now, overall, there's no argument with the planet's natural climate variability, but it's the rate at which greenhouse gases have increased since the mid to late 19th century that we know humans have a hand in warming the planet, leading to implications felt throughout hurricane season, with more intense storms bringing stronger winds, heavier rain, and more damaging storm surge.